Math time. All right, we're on chapter 5, lesson 5 in your big math book. Follow along. If I underline, you underline. Also, you can use graph paper. I would use graph paper. I'm going to be using these boxes in here, but you probably want to use graph paper. You'll see later I'm going to have to do some erasing because I run out of space. So use graph paper, then you'll make sure you'll have enough. That'll make sure you have enough space. All right, let's get started. Students are arranging square tables to make one larger rectangular table, so it has to be a rectangle. The students want to have several ways, so a lot of ways to arrange the tables. Should they use 12 or 13 tables? Okay, so we're going to use this grid to arrange 12 tables, and then we're going to arrange 13 tables. So here they arranged 12 tables in one way. They made a 1 by 12 array of those tables. We could also do a 3 by 4, right? 3 times 4. That would also give us 12, so we can arrange them that way. We could arrange a 2 by 6. Let's see, 1, 2, 3, 4, 5, 6. So a 2 by 6 array. That would also work. Let's see, any other ways? 1, 2, 3, 4 we already got. 5, no, 5 won't work. 6 we already got. Okay, so it looks like we got them all, and really all we're doing is finding the factors. We're finding the factors of both of these numbers. Okay, so now let's try the 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, see, it only goes 12 long. So I'm going to go all the way, and then I'm just going to add my own on the bottom. So now I have a 1 by 13. Well, let's see, is there any other factors of 13 besides 1 and the number itself, 13? Can I do 2 times something? Will 2 work? 2 times, well, another way we could check it is see if 2 will go into 13 even. Oh, whoops, 2 will go into 13 evenly. We can go in 6 times. That'd be 12 minus 1. Nope, there's a remainder. So no, 2's not going to work. What about 3? Let's count by 3s. 3, 6, 9, 12, 15. Nope, we never land on 13. What about 4? 4, 8, 12, 16. Nope, we're never going to land on 13. What about 5? 5, 10, 15. No. So you can see, once you start going through these, we only get these 2. This one arrangement is the only way we can do it. We only get 2 factors. So there are more ways to arrange 12 tables, because that's what we are comparing here, the 12 and the 13 tables. There's more ways to arrange the 12 tables than there would be to arrange the 13 tables. Okay, let's look here. Prime number is a whole number greater than 1 that has exactly 2 factors, the number 1 and whatever number that is itself. So for example, 13 is prime because its only factors are 1 and the number itself, 13. So it's prime. Another example of a prime number would be 5, because the only way to multiply to get 5 would be 1 times 5. So 1 and the number itself. So this is also prime. Can you think of another prime number? Okay, maybe you thought of 2. Maybe you didn't, but maybe you did. 1 times 2, that's the only way to get 2. And so the factors are 1 and the number itself. So that is also prime. So you can see a prime number has exactly 2 factors. The number 1 will always be a factor of any number, and then the number itself. And that's the only way to multiply to get that number. The only way to get 5 is to do 1 times 5. The only way to get 2 using multiplication is 1 times 2. The only way to get 13 using multiplication is to do 1 times 13. The only way to get 17 using multiplication, and using whole numbers, of course, is 1 times 17. So 17 would also be prime. Okay, and there's a lot more examples. All right, so let's look at these 2 numbers, 12 and 13. Sorry about that. The factors of 12 we have up here. There's a factor. Here are all the factors of 12. And we'll put them in numerical order from least to greatest. 1, 2, 3, 4, 6, and 12. And the factors of 13 are right here. We only had 2 of them, 1 and 13. So 12 is a composite number, and 13 is a prime number. Okay. All right. Let's look at number 9. Let's look at 9 real quick. The number 9, not number 9, but the number 9. How can we get 9? We can do 1 times 9, of course, and we can also do 3 times 3. Now, if I was listing these factors, it'd be 1. I only have to list the 3 once, and 9. So 1, 3, I only have to list it once, and 9. So it has 1, 2, 3 factors. So would 9 be prime or composite? Right, it has to be composite because prime has to have exactly 2 factors, no more, no less. So 9 would be composite as well. All right, thanks again for watching, and I will see you on the next video.